The triangle inequalities. We actually have two inequalities that exist within triangles, and both of these you want to know pretty well because you can use them to verify lots of other things in the future. All right, the first that we're going to look at is the side angle triangle conjecture. All right, before I read this part, what I'm going to do is take a look at this random triangle that I have here, and I'm going to take some measurements with it. First I'm going to take measurements of the side lengths. Okay, so for the side lengths I've got, that appears to be 7 centimeters. This appears to be about 8.5 centimeters. And this appears to be about maybe 4.8 centimeters. All right, so we have a scalene triangle. All of the sides are different lengths. All right, now the angle measurements, let's take a look at these. All right, for these I might need to round them a little bit. That looks like it's about 55 degrees. We'll go with that. About 55 degrees. Of course, all the angles are supposed to add up to 180, so if I get really close, we'll work with it. All right, we'll go ahead and call that one 35 degrees. And let's see, this last one appears to be like right at 90 degrees. All right, let's see what that adds up to. Yeah, that actually works out here. These two add up to be 90 degrees. With that 90, we're going to get 180. All right, so I have a random triangle here with these side lengths and these angle measurements. It ended up being a right triangle, but that's just what it was. All right, the observation that we want to make here is about comparisons. That's what inequalities are. Things that are not the same size, they're actually different than each other. And if I take a look at this, I'm going to notice that the 90-degree angle, which is the largest of the angles that we have here, is actually across from the longest side. Now that you might know because of right triangles, the hypotenuse would be the longest one, okay? Now the other ones though, the angle that I have here, 55 degrees, that would be the next largest angle, right? This one is the smallest. The next largest angle is actually across from the 7 centimeters, which happens to be the second longest side that we have. The longest was over here, that would be the second. And then the smallest angle is actually across from the shortest side, the 4.8. Okay, and that is something that will be consistent in every triangle. The bigger angle is going to be across from the longer side. The shorter angle is going to be across from the shorter side. Okay, so our conjecture says if one side of a triangle is longer than another side, okay, let's take a look here. If this side right here is longer than that one, then the angle opposite the longer side, 55 degrees, is blank than the angle opposite the shorter side, okay, which would be the 35. All right, so the angle across from the 7 is actually larger. It would actually be larger than the angle across from the shorter side. All right, that is our first triangle inequality. The second triangle inequality that we're going to look at is typically referred to as the triangle inequality. Okay, and this one actually has nothing to do with the angles. It's strictly about the side lengths that we have here. In geometry, distance is defined as the shortest distance between 2 points. It follows that the shortest distance between points A and C is the line segment AC. So if we had two locations called A and C, the shortest distance between them would just be to draw a straight line from A to C and measure that length. All right, for any triangle ABC, let's go ahead and label this one here. Let's call this A, call that B, and call that one C. For any triangle ABC, AB, the length of that segment, plus the length of BC, this segment right here, would be greater than, all right, remember that this is an inequality, things that are not equal. The length of this plus the length of that side would be greater than the length of AC. And logically, we can probably decide that that would be true. If we had to travel from point A to C, it's going to be shorter to go straight to C versus going over to B and then making a turn over to C. All right, for any triangle, what it really tells us is that we can take the measurement of two sides, and if we add them together, they have to be greater than the length of the third side. Okay, so it doesn't have to just be like AC in this picture. We could look at A and B as one segment plus AC and figure out that that length is going to be longer than BC. Any two sides added together is going to be greater than the length of the other side. Example 1, a triangle has one side length of 12 and another length of 8. Describe the possible lengths of the third side. All right, so we know two sides, but we don't know the other one. There's a range of values that it could actually be, meaning that it can't be super long because you wouldn't be able to build a triangle, and it also couldn't be so tiny that you couldn't close this off as a triangle. Here, let's do a real simple sketch here. All right, so our triangle is not going to look like this. I just want to have three sides there, though. One side is 8, the other is 12. All right, and then we have a side that we don't know, which we'll just go ahead and call x for this. What we learned from the triangle inequality as stated above, if you take two sides and you add them together, they have to be greater than the other side, because the other side would be that straight distance to, like, from one point to another. Okay, so x absolutely has to be less than the sum of the 8 and 12. It has to be less than 20. Assuming that the unknown side is the longest, it must be less than 20. X is going to have to be less than 20. It cannot be greater than 20, right? If you had something like 25, that wouldn't work because it's going to take, a length of 8 to get to here and then 12 to get to there, which is 20. And if you're going to go out to that point and then back, that value needs to be greater than whatever the straight shot distance would be. Okay, so that side needs to be less than 20. Assuming that the unknown side is the shortest, it must be greater than a certain value. Okay, so if we assume that x is going to be the smallest one, that would mean that 12 is the greatest. 12 would be the longest one. Therefore, if we take 8 and x together, they would have to add up to something greater than 12, right? Because 12 is going to be the straight shot distance, which would be the shortest distance between these 2 points. All right, so 8 plus x has to exceed 12. Okay, well, just to get to 12, you would have to have 4. You would need 8 plus 4. So x is going to have to be greater than 4. If it's at 4, the sum of these two equals 12, which doesn't work. As soon as it's just slightly greater than 4, you're going to have enough to veer away from that line and then back. All right, so ultimately we end up with an overall range. If you have two sides and you don't know the third one, the range of values that it can have, it has to be greater than the difference of the two that we know. It also has to be less than the sum of the two that we know. X, here, we'll summarize it here. X has to be greater than 4, but it cannot be bigger than 20. Well, actually, x has to be greater than 4, and it has to be less than 20.
Wait, what?